Let's talk about the basics of hypothesis testing in statistic. First off, hypothesis testing is inferential statistic. So when we do inferential statistic, we have a claim about a population parameter that is going to be tested and decided upon. The formal process to test accepted claims about the population is called hypothesis testing. Here, the new hypothesis, which is called the alternative hypothesis, is tested against a value that we have previously set up. We call that the null hypothesis. The alternative hypothesis is the evidence the research has against the null hypothesis. In the process of hypothesis testing, we are proving whether that evidence is sufficient or statistically significant to reject the null hypothesis. In other words, we do this study and we get this new mean for something. All right, let's just make a formal example in here for doses of medicines for kids. Very simple example. We know what the doses is for, say, an example, ibuprofen for kids, and the doses is regulated or determined by the weight and the age of the kid. Those are doses that are predetermined. They have been determined previously by other research. If we go ahead and we do a new study and we find a rather different mean for the doses for any of the age groups, then what we are going to do is we're going to test that new value, that new evidence that we as a researcher are collecting against what it's previously known as the doses, which is your null hypothesis. So that new evidence that I have, that's going to be my claim, that is the alternative hypothesis in the process of hypothesis testing. Let's talk about problem number 1. A mortgage lender states that credit card holders have a balance of $1,200 on average. A loan officer believes credit card holders have a larger credit card balance than stated by the mortgage lender. So from previous knowledge, we know that on average, someone that has a mortgage, like a mortgage lender, the holder for the credit card has a balance of $1,200. The loan officer believes that that number is too low and that the credit card balance for the stated mortgage lender, it's larger than $1,200. He goes ahead and he obtains a sample. So after obtaining a sample from the credit card customers, the loan officer finds that the credit card balance is $1,305 on average, right? So the 1,305 is the mean of the sample obtained by the loan officer. So using our vocabulary, this 1,305 is a statistic because it belongs to a sample. As the loan officer sets up a hypothesis test to determine if their beliefs is correct, what is their claim? What is the claim of the loan officer? What are they saying? They're saying that the average credit card balance, it's greater than $1,200, which is the previous, right? We had previous knowledge of that balance being 1,200 on average, and he believes it's more than that. He gets the sample and the mean is 1,305. So he has some evidence that the credit card balance is larger than 1,200. So the correct answer for the claim is this one, right? The loan officer is claiming that credit card holders have a larger balance than the 1,200 the mortgage lender states. Problem number 2. In a recently published article, the average amount of time a stockholder owns a stock is 56 weeks. A finance advisor believes their clients hold on to stock in less time. Interested in studying this further, the financial advisor samples their clients and finds that the amount of time a stock was owned was actually 50 weeks on average. So again, 50 weeks, that it's coming from the sample that the financial advisor obtained. Thus again, this 50 is your statistic. So that is your new number. So that's the number that you are going to use as an evidence for your claim. So as the financial advisor set up a hypothesis test to determine if their belief is correct, what is the financial advisor's claim? So the correct answer is that the average amount of time a stockholder owns a stock is less than 56 weeks. So again, we need to create the claim using the number that we previously had, because his evidence is that actually the time is less than the previous 56 given to him. All right, so again, this is the correct answer. The financial advisor is claiming that the time the client hold on to stocks is less than the 56 weeks the article is stating. Problem number 3 in the same line. After running a mile a day over a period of 2 weeks, the average amount of weight loss is 2.5 pounds. A dietitian who publishes health articles in a newspaper states their new diet program helps with additional weight loss when combining their special diet with running a mile a day over a period of 2 weeks. So helping with additional weight loss means that actually the person is losing more than 2.5 pounds. Interested in studying the dietitian's article further, you ask friends who have tried the dietitian's new program, and you determine the weight loss to be 3 pounds in a 2-week period on average. So again, the 3 pounds, it's the average of weight loss for your friends. Those friends are your sample. Thus again, this 3 pounds, it's your statistic. It's the number coming from the sample. That is not the number that we use to create our claim. Our claim needs to be based on the 2.5. All right. So then as you set up a hypothesis test to determine if the dietitian's article is correct, what is the dietitian's claim? So again, what is the claim? The claim is that the average amount of weight loss, it's greater than 2.5 pounds because she had an evidence of something larger than that, which is the 3. The dietitian is claiming her new diet is going to help with more weight loss than the 2.5 pounds previously known. All right, so moving from claims, we can do hypothesis testing in 2 different ways. We can do a critical value approach, or we can do a p-value approach. They're similar in a way, but we look at it's different. But this figure here should be something that you are familiar with. We have our normal bell curve, and we have the rejection region in the tails, and that rejection region is created by critical values. Remember the normal distribution is symmetric, so the area on the underneath the curve for both tails is the same. So this red shaded region is the same as this red rigid shaded region. So the critical value should be the same, but positive and negative, right? Because I'm centered here at 0. So when we use a critical value approach, this allows us to create a rejection region, which determines if your test statistic is enough to support a claim or not. The test statistic is a value that is coming from the numbers that you get from your sample. Given a desired significance level, the null hypothesis can either be rejected or fail to be rejected based on the test statistic, again, that's coming from the sample data, and the critical value, which is coming from the significance level. Following this approach, you compare the test statistic with the critical value. So the critical values are going to be here, right? So this is critical value and this is the critical value. So you compute the test statistic. It has a formula to it. You compute that value. When you get that value, you are going to see if your value is greater than the positive critical value or smaller than the negative critical value. If it lies in the red region, then you have evidence to reject the null hypothesis. If it is inside your critical values, from the negative to the positive in this white region, then you fail to reject the null hypothesis. So you compare those two numbers. The critical values are z-scores from the normal distribution, or t-scores from the t-student distribution, depending what we're doing. But since you have worked with the normal distribution before, think about critical values as those z-scores that we talk about being so many units away from the standard deviation from the right or from the left. So that's what we do to compare or to decide if we have the evidence to reject or if we fail to reject the null hypothesis based on a critical value approach. Next one is a p-value approach, all right? And then maybe I should go back here and say that this desired significance level, it's the alpha that we decide for our testing. It can be a 5%, a 10%, that needs to be determined ahead of time, and then that's the alpha that we use. I'll talk about that in a future video. When we talk about the p-value approach, the p-value approach involves determining likely or unlikely by determining the probability, assuming the null hypothesis were true, of observing a more extreme test statistic in the direction of the alternative hypothesis than the one observed. Following this approach, we compare the p-value with the significance level. And so again, I have a picture in here. We have that normal distribution again. The p-value is the area under the curve from a point, from the observed data point on. And so what we do is we compare, p-value is going to be a proportion. So again, it's going to be a number between 0 and 1. We have, we compare that with the alpha. And again, the alpha is what we mentioned here, the significance level. So significance level is alpha. So we're going to compare that alpha, which we use 0.05 a lot, but it depends on what the significance levels we are using is. But if the p-value is larger than the alpha, then you fail to reject the null hypothesis. Now you need to think about p-value and alpha as areas under the curve, all right? So then let's just say that alpha is just at 5%. So you have 0.05 in your, you have a 0.05 as your alpha. So let's just say that 0.05 is up to this point. All right, so here. All right, hold on. Let me see if I can. I'm just trying to get the pencil to write. All right, so let's see. Let's say that this in here is your alpha value. All right. So then this, if the p-value is greater than the alpha, it means that you have more area on the tail, like this in here. So if the p-value goes all the way here, you're covering more area than what the alpha is allowing you to cover. So then you are in that rejection region again, like the picture before. If the p-value is less than the alpha, then this is the alpha. The p-value is going to be here, getting less area in the tail than the alpha, then you have evidence to reject the null hypothesis. So when we are doing the hypothesis testing and we are using a p-value approach, we want to have a p-value that is very, 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 very small, so that it's smaller than your alpha. And then what you have as evidence is enough to reject the null hypothesis. So terms in here, and I have talked about these terms before, but just to kind of recap what we are doing, critical value, it's a computed value based on the significance level and the type of test that we are doing. This is the value that is going to create the rejection region for us. So again, the critical value, it's like a z-score. It's going to depend on the significance level, because the significance levels tells me what is the area that I want on the tails. And the type of test, because we're going to be talking about a z-test and a t-test, depending on the information that we have. And we're going to talk more about different type of tests and how we use them in a future video. The p-value, again, is the probability calculated based on the test statistic. That p-value depends upon your sample, like what you're getting on your sample, same as the test statistic. The test statistic is a value computed from the sample data, which is used to compare the sample data to the population parameter. Remember that if we use a critical value approach, we compare the test statistic with the critical value. If we use the p-value approach, we compare the significance level with the p-value. The significance level is a value that is set ahead of time that allows the researcher to make a conclusion about whether their sample statistic is different enough than the claimed population previous set value. And we'll continue mentioning all of these words as we move forward. So let's talk about how do we recognize if we are talking about a critical value, a p-value, test statistic, significance level, and all that. So problem number 4. A dental hygienist is interested in the number of cavities teenagers have when they visit the dentist. She believes, or the dental hygienist believes, the average number of cavities is more than 3 cavities and would like to test this claim. During the process of hypothesis testing, the dental hygienist computes a value that is based on the significance level and the test type. So what is a value that is based on the significance level and the test type? So remember that this is the critical value. The critical value is like that z-score or t-score that is going to be based on that probability that I want, or that percentage that I want to have in my tails. And it depends on the test, because if it's a t-test, then I use a t-distribution. If it is a z-test, then I'm using the normal distribution. All right, so the value based on the significance level and the test type, it's called the critical value. Problem number 5, Joanna, a machine learning engineer, is studying What programming languages are the most effective to help systems learn from data? Based on previous research, more than 50% of machine learning involves the use of Python, a programming language. She suspects this percent has increased in recent years. So again, in the process of hypothesis testing, what is the set value that will allow Joanna to make a conclusion about whether her sample proportion is different enough than the claimed population proportion? So again, that set value, that value that we set ahead of time, is the significance level. So like if you will see problems that says conduct this hypothesis testing with a significance level of 5%. Before you do anything, that's something that you will know ahead of time, right? So the significance level is ours an a priori set value that is compared against the p-value to make conclusions about our sample. It is also used to compute the critical value. That's why it is so important to set that value beforehand. Problem number 6. Heather, a sociology major, is interested in studying mass media topics. She is particularly interested in the percentage of mass media topics that relate to entertainment. Based on previous research, 72% of mass media topics relate to entertainment. She suspects this percent is different. During the process of hypothesis testing, she calculates a probability using the test statistic. What is the probability associated with the test statistic? So again, probability that uses the test statistic. You have two sort of probabilities in this context, the p-value and the significance level. And they are probabilities because we're talking about area under our curve, all right? The significance level is a number, probability, that is set up in advance. The p-value is the one that it's associated with the test statistic and that we compare at the end of the process with the significance level to determine if we have evidence or not to reject the null hypothesis. Problem number 7. A financial analyst is interested in the percentage of investors who have bonds in their retirement portfolio. Based on previous research, 25% of investors have bonds as a part of the retirement portfolio. The financial analyst suspects this percent has increased in recent years. During the process of hypothesis testing, what does the financial analyst need to compare their test statistic to in order to make a conclusion? So remember that the test statistic is compared against the critical value in the critical value approach. So this is the correct answer because a critical value approach allows us to create a rejection region. The critical value is the one that allows us to create a rejection region, which determines if our test statistic is enough to support our claim. Moving on to problem number 8. A finance blogger is writing an article about credit card use. As they write the article, the finance blogger is interested in the average number of credit cards per adult. Based on previous research, an adult has 4 credit cards on average. The finance blogger believes this average is different. If the finance blogger chooses a p-value approach, what does the p-value need to be compared to in order to determine if there is enough evidence to support their claim? So p-value approach compares the p-value against the significance level, right? If the p-value is smaller than the significance level, we have the evidence to reject the null hypothesis. If the p-value is bigger than the significance level, then we fail to reject the null hypothesis. Problem number 9. A money management firm which specializes in debt reduction is interested in the average amount of debt for a married couple. In previous years, married couples had $4,500 on average of debt. Due to increased cost of college and mortgage interest rate, the money management firm suspects this average has increased in recent years. If the money manager firm carries out a hypothesis test, what forms the rejection region, right? So null hypothesis is the hypothesis we are creating with the previous information that we have. A test statistic is a value that we compute out from the information from the sample. P-value, it's a probability that we compute using the test statistic to find area under the curve to the right of the test statistic. So what forms the rejection region? The critical value. And then if you remember the picture that I had in here a couple of slides before, the critical value, it's based on the significance level and test type, and then it's used to create that rejection region. When I have the tails shaded on red, I'm showing you that that was the rejection region. Problem number 10 and last one. A doctor is measuring body temperatures for patients visiting the office. The doctor believes the average body temperature is less than 98.5 degrees Fahrenheit and would like to test this claim. During the process of hypothesis testing, the doctor computes a value from the sample data, which will be used to compare the sample data to the population parameter. What value did the doctor compute? So again, critical value, it's compute from the significance level. Test statistic is compute from the sample data. P-value and significance levels are probabilities. So the correct answer is going to be the test statistic.